Next, we're going to use our graphing calculator, so I want you guys to get those out. And we're going to need to turn diagnostics on. Okay, and I'll show you guys how to do that, but I gave you steps there as to what to do. This is going to give us that R value and our R squared value. So when we turn the diagnostics on, it lets you see those R and R squared. So that's the first thing that says here. You guys can also follow those steps or follow along with me in the calculator. So the first thing we want to do is go to the catalog, and if you guys remember, the catalog is second 0, and it says that on your paper. It has this little A here, and that means alpha. So notice how alpha is in green. That means you can use the letters. So here I have a green D, so I'm going to hit that to get closer to the D's. You can always just use your down arrow, but we're going to have to go down arrow anyways until we get to diagnostic. So notice how it says diagnostic on. That's what we want to do, so I'm going to hit enter. I have to hit enter one more time to make sure it's turned on. So now, anytime I do a regression, I'm going to see the R and R squared values. Now, if I happen to clear my calculator, like doing my second plus 712 again, you'd have to turn diagnostics back on. All right? But otherwise, it's going to stay on the entire time that you are using your calculator. Next, we're going to actually go to example 2. So now in example 2 here, we have all of the same X values here, but we're given different Y values. And we're going to find these different types of positive correlations. On each of these, the Y values are increasing, so that means we have a positive correlation. We're going to look at the scatter plots. All right, so remember we have to turn our stat plot on and use zoom 9, and we'll talk about that in a minute. And then we're going to find those R values of the correlation coefficient by finding our linear best fit to the nearest thousandths. Okay, that is 3 decimal places. So we're going to round to 3 decimal places. All right, so we're going to have to enter our data in the list. So we're going to have list 1 and list 2. We're going to do our linear regressions, right, just like we've been doing for the past few days. So I'm going to go ahead and start here. So to enter data in a list, I'm going to use my statistics key. So we're going to do stat. We are editing a list, and we're going to enter our data into list 1. So the X's are going into list 1. So we have 2, 5, 8, 11, 15, and 18. Now those X values aren't going to change, so we're going to be using it throughout the entire examples. The next one are my Y values. So here is where we're going to enter the Y values that are given. So we have 4, 13, 22, 29, 43, and 52. So now that I have those values entered, I'm going to go ahead and look at the scatter plot. Now remember, it says stat plot here. It's in blue, so I need to do second Y equals. Right now it's turned off. So in order to turn it on, I'm going to hit enter. Notice that the on is blinking. It is not highlighted, so I'm going to hit enter, and now on is highlighted. In order to see the scatter plot, I need to do zoom 9. This looks like a pretty straight line. So when I figure out what my R value is, it's going to be very close to 1. So to actually calculate that, I'm going to do my statistics key. We are calculating something. And remember, we're going to do a linear regression for all of these. So I'm going to go down to number 4 or type in 4. Now, depending on your calculator, you might have to enter list 1, comma, list 2 if your screen looks different than mine. So remember, that is second 1, comma, second 2. Now list 1 and list 2 are already here, so I can just use my down arrow, keep hitting enter till I calculate. Notice that now, different than the past few days, I have R squared and R. When I round to 3 decimal places, I get 0.999. This tells me that there is a strong positive correlation between the 2 variables in the data set. So a strong positive correlation. We're going to continue to do this for the other 3 examples, B, C, and D. So again, X's are the same, list 1 is the same. So I'm going to do my statistics and edit. We're editing list 2. I want to clear it, so I use my up arrow, clear, down arrow. Now we're entering these new pieces of data. So I have a 16, 14, 22, 41, 37, and 51. I want to see what the scatter plot is. Since it's already turned on, I just need to do zoom 9. Now this is still pretty much in a straight line, but not quite as much so as the first one. So it should still be pretty strong, but not as strong as the other one. So I'm going to go ahead and type in statistics, calculate, number 4, all right, and I can hit enter to go down here. And now my R value is still pretty good. It's 0.930. So this is a still strong, right, positive correlation. It's not quite as strong as the other one, but it's still a pretty good line of best fit. All right, 2 more times. So now again, I'm changing just the Y's. I'm changing the list too. So I'm going to go to my statistics, editing my list, up arrow, clear, down arrow, and now we're going to go ahead and enter this piece of data, okay? So our first number here is 18, 8, 41, 28, 62, and 44. So now I want to look at the scat plot. So I'm going to do zoom 9. And it's a little more spread out. Still positive direction, a little more spread out than the others. So I'm going to go ahead and calculate what my R value is. So stat, calc, 4, keep hitting enter, or my list 1, list 2, depending on what you have. Notice this time my R value is 0.776. So that is a positive correlation, but not quite as strong, right? So one more for the positive. So again, I'm going to do my statistics. I am editing my list. I'm going to clear this out. And now I'm going to enter my data. So I have 44, I have 51, 30, 55, 45, and 47. Zoom 9 gives me my scatter plot. Now this one's a lot more spread out. So let's see what our R value is this time. So I use my stat. We are calculating something. We're doing number 4. Again, I'm calculating here. And this time, our value equals 0.133. So this would be, we can consider this a weak or no correlation. So this time our data was pretty scattered, all right? It wasn't in a straight line. So now we need to answer part D. And this time it says, how does the correlation coefficient, how does this R value quantify the fit for the positive correlation? Remember, quantify means number. All right, so here, the closer R is to 1, the stronger the correlation, right? The closer R is to 0, the weaker the correlation, or no correlation, depending on how close, right, it is to 0. So that is for a positive correlation. Next, we want to look at a negative. So notice now my y values are decreasing. If they're decreasing, that means that it's going to be a negative correlation. So we're going to do the same thing here. So we're going to go ahead and hit our statistics. We are still editing, right? I'm going to clear out my list, enter my new values here. So now I have 52, 47, 28, 32, 25, and 10. So this time when I do my zoom 9, I notice that those values are decreasing when when x increases, y is decreasing, it's going down. So I should have a negative R value or a negative correlation coefficient. So when I calculate this, just like we've been doing, okay, it's hard to see, but notice that it is a negative value here. So this time R equals negative 0.945 when we round. Okay, so this is telling us it's pretty close to -1, right? So it's a strong negative correlation. Right, R is close to -1. Right, so that is correlation coefficient. There are 2 questions on the next page. I want you guys to go ahead and answer them, and then, so pause now, and then compare your answers to what I get. So go ahead and pause. Okay, now we're going to compare your answers to mine. So in this case, we want to look at here, we have a scatter plot, and we want to know which R value would best represent the scatter plot, and we're going to explain our answers. Well, the first thing I noticed that it's pretty close together and it's going up as x increases, y increases, so I know it's going to be positive. This value is not positive, so I'm not going to include it. It is pretty strong, so I'm going to get rid of this one because that would mean a weak or no correlation. So now I got to decide between choices 1 and 3. It's not in a perfect straight line, but it's pretty close. So I can't really be 1, and that's why I'm going to choose choice 1 here. All right, so that's for the positive. This next one is we want to look at these examples and which one has an R value close to -1. So remember, when R is -1, this means a strong negative correlation. Right, this is saying R equals -1. So this first example is positive, so that can't be it. This is scatter, so this would really be no correlation. These are both going down, so I need to decide between the 2. This one looks pretty good, right? But this one is a little closer together. This one looks a little bit more like a straight line. This one would be stronger or have an R value closer to -1 than number 2. So that's why I chose that one. All right, so I'm going to end this video here. I want you guys to go ahead and watch the next one on residuals and residual plots.